Hello boys, good morning. It's good to have classes with you again, and I hope all of you are just having nice time with your new class performance as you have promoted to next class, and now you have to take preparation focusing on your board exam. And we are just continuing with chapter 11, current electricity, and we have learned about the primary topics from this chapter. Some topics like in last class we have learned, we have known about the primary idea of a circuit. Before describing a circuit in today's class, I want to discuss about the topic equivalent resistance. That is also an important one, but for knowing circuit, or for simplifying a circuit, for measuring the circuit current, for measuring the voltage drop across various resistors, we have to know about equivalent resistance. That's why in today's class I will discuss about equivalent resistance, and then we will just get back to the circuit again. We will try to solve some circuit. We will try to get some get the current, the voltage difference from different kinds of circuit. But first of all, we will try to know about equivalent resistance. So you have got the idea of resistors. The resistance or resistor is the blockage or hindrance in flowing of current through a conductor or through an element. So what is called equivalent resistance? If we want to say about equivalent resistance in a circuit, if we use more than one resistor, that means 2 or 3 resistor in a circuit, then instead of, for example, in this circuit, this is a simple circuit. Here I'm using 3 resistors, R1, R2, R3. So instead of using more resistors, if we can replace these resistors by using one resistor, that will provide the same amount of current and voltage difference. That is called equivalent resistor. অর্থাৎ একটা সার্কিটে যখন একটার পরিবর্তে অনেকগুলো রোধ বা রেজিস্টর ব্যবহার করা হয়, সেটা না করে তার পরিবর্তে যদি আমরা এমন একটা রেজিস্টর বেছে নিতে পারি, যে রেজিস্টরটা সেই কম্বিনেশন অফ রেজিস্টরের জন্য যে পরিমাণ কারেন্ট প্রোভাইড করতো, যে পরিমাণ ভোল্টেজ ডিফারেন্স প্রোভাইড করতো, সেই একই পরিমাণ কারেন্ট এবং ভোল্টেজ ডিফারেন্স সেই একটা রেজিস্টরই প্রোভাইড করবে, সেই সিঙ্গেল রেজিস্টরটাকে আমরা বলবো ওই কম্বিনেশনে ইকুইভ্যালেন্ট রেজিস্ট্যান্স। ফর এক্সাম্পল এটা RN দিয়ে ডিনোট করলাম। So what is equivalent resistance? Instead of using more resistors, if we can replace those resistors by one single resistor, that is called equivalent resistance. This is an important concept in knowing about circuit, or just simplifying a circuit. There are two types of combination for measuring equivalent resistance. One is series circuit, and another is parallel circuit. Series circuit and parallel circuit. For measuring equivalent resistance or in a circuit, if we design the resistors, then we can design them in 2 ways, either by series connection or by parallel connection. Series circuit or parallel circuit. What is meant by series circuit? If we want to say about series circuit, in this type of circuit, the resistors are connected in series. That means after the ending point of one resistor, at the end point of one resistor, we will connect another resistor, and thus we can connect 2, 3, 4 as much as we like. 3, 4, 5, 6 as our wish. We can, according to our demand, we can connect resistors over here. This is the voltage source, and these are the resistor. Just look at the diagram over here. after the end of every resistor, another resistor is connecting over here. That means একটা রেজিস্টরের শেষ প্রান্তে আরেকটা রেজিস্টরের শুরু প্রান্ত যুক্ত হলো, ঠিক আবার সেকেন্ড রেজিস্টরের শেষ প্রান্তে থার্ড রেজিস্টরের শুরু প্রান্ত যুক্ত হলো, এবং সেটা লাস্ট রেজিস্টরটা সার্কিটের যে নেগেটিভ এন্ড সেখানে গিয়ে যুক্ত হলো। এই ধরনের কম্বিনেশনকে আমরা বলবো সিরিজ কম্বিনেশন। R1, R2, R3. So series combination, in case of series combination, what will be the equivalent circuit? If we denote the equivalent circuit as RS, because this is series combination, that's why we are denoting as RS. RS is equals R1 plus R2 plus R3. That means after directly adding all the values of resistors over here, we will get the equivalent resistance. Series combination এর ক্ষেত্রে যেটা আমরা বলবো, সরাসরি যে রেজিস্টর গুলো একটা সার্কিটে ব্যবহার হয়েছে সবগুলোকে যোগ করে দিলেই আমরা কি পেয়ে যাব, সিরিজ কম্বিনেশনের জন্য বা সিরিজ সার্কিটটার জন্য ইকুইভ্যালেন্ট রেজিস্টর পেয়ে যাব। In series combination, we have to keep in mind some point over here. First of all, the equivalent resistance will always be greater than the value of largest resistor. Will always be greater than the value of largest resistor. That means here we are using 3, 4, 5, 6 or more resistor. For example, here I have used 2 ohm, here 5 ohm, and then 100 ohm, for example. As we know that the unit of resistor is ohm, so we are using ohm. We can use ohm, kilo ohm, mega ohm, that means larger units for measuring the resistors, but in most of the cases for simple circuit, ohms are used as the unit of resistor. So what is the line I have mentioned over here? The equivalent resistance, if we measure the equivalent resistance for these resistors, what will be the equivalent resistance? R is equals, just we will make a summation of all resistor, 2 plus 5 plus 100, that means 107 ohm. So what is the line I have mentioned here? The equivalent resistance is getting larger than the largest resistor of this combination. In here I have used 3 resistors for making a series combination, and the largest one is of 100 ohm, but whenever I have determined the equivalent resistance, that is 107 ohm, it is larger than the largest resistor that I have used in this combination. We have to keep in mind that in equivalent resistance, for series combination, the equivalent resistance will be greater than the greatest or largest resistor of that combination. Another important term, or most important term for series combination, is that in series combination the current is same for every resistor. This is a very important point. The current is same for every resistor, but the voltage difference here, for example, for this voltage source, a current will try to pass through the circuit, and that is denoted by I, total current of the circuit. So as all the resistors are in series connection, the current will just go on a single path. That's why the current will be same for every resistor. If we measure current across these resistor or across the R3, in all case the current will be same, because this is in series combination. The current will just go through a single path. But while passing the current through all these resistors, there will be voltage drop across every resistor, and that's why voltage difference for every resistor will be different. The current is same for every resistor, but the voltage difference or potential difference will be different for every resistor. Will be different for every resistor because the resistance are of different values. All the resistance are of different values, so through all resistor amount of voltage will drop over here, and that's why if we measure the voltage difference or potential difference of every point, for every resistor, প্রত্যেকটা রেজিস্টরের দুই প্রান্তের potential difference আমরা যদি measure করতে যাই, that will be different. Okay, we have to keep this point in mind for our assumption for calculating current for simplifying a circuit, that in series circuit current is same for all resistor, but in case of parallel circuit the case is different. So we have known about series circuit, what is called series circuit, and what is the equation for determining the equivalent resistance for a series circuit. Now we will try to know about parallel circuit. What is called a parallel circuit or parallel combination? Whenever the resistors are just connected in such a way that for example, resistors are connected in such a way that all the starting points of all resistor are connected to a single point of source, and all the ending points of all resistors are connected to the another point of source. For example, in this circuit I've used 3 resistors over here. If you just observe the circuit here, all the starting points for R1, R2, R3 are just the same, and they are connected to the positive end of the battery, and all the ending points of resistors, they are just a single point, and they are connected to the negative point of a battery or source. তো প্যারালাল সার্কিট আমরা কিভাবে বুঝবো? যে সার্কিটের রেজিস্টর গুলোর শুরুর প্রান্ত একসাথে থাকবে এবং শেষের প্রান্ত একসাথে থাকবে, এবং শুরুর প্রান্তগুলো কম্বাইন হয়ে ভোল্টেজ সোর্সের একটা প্রান্তে যাবে এবং শেষের প্রান্তগুলো কম্বাইন হয়ে আরেকটা প্রান্তে যাবে। এই ধরনের সার্কিটকে আমরা বলবো প্যারালাল সার্কিট। সরাসরি তারা যে ভোল্টেজ সোর্সের সাথে কানেক্টেড হতে হবে এমন না, তবে সিরিজ সার্কিটে একটা বিষয় খেয়াল রাখতে হবে যে রেজিস্টরগুলোর স্টার্টিং পয়েন্ট একসঙ্গে থাকবে আর এন্ডিং পয়েন্ট একসাথে থাকবে, then we can call it a parallel circuit. So if we want to determine the equivalent resistance for a parallel circuit, that will be 1 by Rp. Here Rp is denoting as equivalent resistance for parallel circuit. 1 by Rp equals 1 by R1 plus 1 by R2 plus 1 by R3. Here, as we have used 3 resistors over here, if we use more resistors, that will be calculated over here. We can use n times resistors over here as our requirement. So on that case, if we simplify this equation, what will we get over here? R1, R2, R3. Then what will we get? R1. That means ultimately for parallel combination, if we just write it as a our ultimate requirement is that, or our ultimate target is to determine the Rp or equivalent resistance or for parallel combination. So simply we can write it in a form like that: Rp equals 1 by R1 plus 1 by R2 plus 1 by R3 inverse 1. That means after combining all resistors, if we make the reciprocal of this term, then we will get the equivalent parallel প্যারালাল ইকুইভ্যালেন্ট রেজিস্ট্যান্স ফর দিস সার্কিট। অর্থাৎ যদি আমরা প্যারালাল ইকুইভ্যালেন্ট রেজিস্টর বের করতে চাই, যেটাকে আরপি দিয়ে ডিনোট করছে, আরপি এখানে ডিনোট করছে প্যারালাল কম্বিনেশনের জন্য ইকুইভ্যালেন্ট সার্কিট। তো সেক্ষেত্রে সবগুলো রেজিস্টরের রেসিপ্রোকাল টার্মগুলোকে আমাদের অ্যাড করতে হবে, এবং ফাইনালি আরপি যদি আমরা ডিটারমিন করতে চাই সেই কম্বিনেশনটাকে আবার রেসিপ্রোকাল করতে হবে। সেটা যদি করি আমরা প্যারালালি ইকুইভ্যালেন্ট সার্কিট পেতে পারি। For example, if you just try to add some resistor, for example, in the circuit R1 is equals 1 ohm, R2 is equals 2 ohm, R3 equals 3 ohm, then what will be the equivalent resistor? 1 by Rp is equals 1 by 1 plus 1 by 2 plus 1 by 3. Then after adding all these resistors, we will, what can we get over here? 6 plus 3 plus 2, then 1 by Rp is equals 11 divided by 6, 11 by 6. Then what will be the value of Rp? The equivalent resistance Rp will be the just reciprocal of this combination. Thus we can measure the equivalent resistance for a parallel circuit. So we have known about series circuit and parallel circuit, but in some cases we have to use the combination of both. That means combination of series and combination of parallel circuit. That means a simple circuit will include both the series combination and parallel combination. So in our next class we will try to discuss some circuit that consists of combination of both series and parallel resistor, parallel combination of resistor. আমরা আমাদের নেক্সট ক্লাসে কিছু সার্কিট ডিসকাস করার চেষ্টা করব যেখানে এই সিরিজ কম্বিনেশনে থাকবে, প্যারালাল কম্বিনেশনও থাকবে। ফর ইয়োর এক্সাম মোস্ট অফ দ্য টাইম যেটা হয় যে একটা সার্কিটে একসঙ্গে সিরিজ কম্বিনেশন এবং প্যারালাল কম্বিনেশন থাকে। জাস্ট সিরিজ একটা সার্কিট দিয়ে দিবে বা প্যারালাল একটা সার্কিট দিয়ে দিবে এমন না, দুইটার কম্বিনেশন মিলিয়ে এক্সামে প্রশ্নগুলো আসে এবং সেইগুলোকে কিভাবে সিম্পলিফাই করতে হয়, equivalent total, how to measure the total equivalent circuit of a combinational circuit, and to how to measure the total current, we will just try to know on our next class. So boys, আজকের ক্লাস এতটুকু। I hope you have got the point over here and all the terms are clear to you. If you just practice after attending this class, if you just practice including by taking the help from your book, everything will be clear to you. And see you on next class. Till then, goodbye. Thank you all.